So good evening, guys. Welcome back once again after the minors. Hope your minors went well. So first thing first, after the minor, uh, there will be term paper. Apart from the tutorial that is going on, you must be aware that there is a term paper that you have to submit somewhere near the November and also before the minors, of course, before the majors. Uh, so Ridhima, would you like to explain the details of the term paper?
And I'll share that and share
Okay.
those instructions. Just a
Yeah.
second.
So those instructions have already been uploaded on Moodle also, and now she's sharing it here also.
Yes, I've shared the term paper. Just a second. Abhishek, can you share your screen?
Yes, I'm sharing.
Mhm. Uh, so I don't think so. You people have done any term paper before, so this must be the first term paper that you'll do. So the basic idea for any term paper that you might do in your further courses is that it is a kind of a review that you do for a research journal or paper that has already been published, and then you extend its like the findings. um, First you replicate all the findings of that research paper, and then you, if you are able to, you extend the findings too. So firstly, you need to find an appropriate research article that you think you would be able to replicate, and that you see like it has the potential that you can extend it, or you can like there's some future scope, or there's something you can um, do on your own, like related to that problem statement or related to that research topic. So you can use like simply you can Google the terms, like you can whatsoever methods you have learned till now, or you can just use other methods too, like that are there in the syllabus, and you can simply Google, or you can use Google Scholar. Specifically Google Scholar, you can use the filters there. I mean, it really increases the efficiency of your search. So on Google Scholar you will see only the research papers, and it would be helpful. If you do a simple Google search, you get like a lot of results that are not that might not be important, and so use Google Scholar. So just remember, I'll type in here. And Now, specifically about the marking scheme of this term paper, so you have to make teams of 4, and every student should, like, obviously, ideally should contribute equally to the paper, and all of you know how to generate a Turnitin report, or how to check for the similarity percentage using Turnitin. Have you people used Turnitin before? Just raise your hands if you know about Turnitin.
No, ma'am, we have not. I have not used.
Okay. So uh, we'll let you know, like, uh, you'll need it only when you have to submit the term paper. So there's time, and we'll tell you how to use Turnitin. For now, what's important is you need to firstly select your term paper, and if you have any problem while selecting the term paper, or you need any help, so you can just ask us, or you can just write an email or send, like, post it on that doubts channel. So we'll reply to your problems, to your doubts, and so you have to make teams of 4, and then these are the subheadings of your term paper, like the abstract, introduction, problem formulation, and numerical analysis. They are like, ma'am has already explained very well what you need to include these subheadings, and you you cannot copy directly from the research journal, because we'll know, because of, so you need to write everything based on your understanding of that research journal. And also, you should know that all the findings in that research paper, mostly uh, most of the research journals, they don't provide the source codes, they only provide the results, and they just like, give an idea of how they wrote the pseudocode or something like that. They don't give the entire C++ or Python code. So you need to judge that you'll be able to replicate it or not, and if you think that you won't be able to replicate the results, then you should not opt that paper, because you can see here the marking scheme is pretty straightforward, and you'll, like, lose on marks if you're not able to produce the codes. So, and also you cannot cheat in your codes. You cannot, like, directly copy even if they're available with the research journal. um, so yeah, that's the thing, and you get extra marks if you are able to go beyond your research journal. So this is pretty simple. The self-assessment, you just need to write a self-declaration kind of thing, all for a few, like, what you think of the paper, how was your understanding of the paper, the path forward and conclusion. Even if you're not able to produce any codes, like, or any results that are um, like beyond the scope of research journal, you can just in the path forward subheading, you can just give a simple hypothetical situation, or a very basic, a vague idea of what you think these findings can be, like, what is the potential of this research journal, how it can be used further. So that's also, this is optional, but yes, you can just write even without any codes, but if you produce the codes, you will get more marks. So yeah, that's it. And yeah, and related to the submission and everything, and the Turnitin report, we'll show you how to generate the Turnitin report. That's pretty simple, and yeah, we can talk about it later. So right now you just need to select a research article, a journal, and then just try to understand what's in there. for now. You need not to worry about the submission details. Yeah, and form your groups too. That's it. Do you have any doubts?
Ma'am, can you please once again explain the level 2, like what is expected from us in level 2?
Okay, so just a very basic example. If in your if in your research article it's given that how can I explain? If they're finding out the superficial velocity of something like in two-dimensional for a two-dimensional geometry, and you are able to find superficial velocity for a three-dimensional geometry, then that would be like you're going beyond the scope, like beyond what has been done and what has been published. It is your own work, like something that you have done on your own based on your understanding of the article and this course. So that's level 2.
So level 2 is just the extension of what you have done in the original paper, what is being done in the original paper. Just like as Ridhima told, it can be just extension from 2D to 3D problem, or anything can be. You can introduce new parameter and analyze new things. You have to just think innovatively about what can be done new with given information. For more details, we will upload the sample papers of past years, which have done level 2, level 1, and level 0 kind of work. So it will give you a better idea of how to go about it.
uh,
I hope.
and also another example is that you can increase the accuracy, like the accuracy of the results, or if you're doing using some ML algorithm, then you can like again increase the like accuracy, etc. And also you can extend it, like this is a finding that I feel, this is a result that I feel can be used in this real life problem, which can like solve this real life problem. Like that article is purely theoretical and you're able to implement the result of that article to solve some problem that you see in your daily life or something like that. So it is it really depends on you how you want to extend it. Yeah, that's, and yes, we'll share the examples. Anything else?
Thank you.
Cool, then I'm sure I think we can start with the tutorial sheet. You can also post your doubts in the chat section.
Yes, yes, yes. Start. So guys, have you all read the problem? If not,
Yes.
yeah, yeah. So someone would like to tell what is there in the problem, or I will give you 5 minutes. You read, all of you read the problem and then tell me, so that everybody gets it properly. Okay. So after 5 minutes, we'll discuss that what we have to do in the problem.
Excuse me, sir.
Yes, go ahead.
I was reading the problem, and there you have given the error tolerance to be 10 raised to power 5. Shouldn't it be minus 10 raised to power minus 5?
Yes, there is a typing mistake there. It should be 10 to the power minus 5. So everybody read the question now. So would someone like to go ahead and explain what is being asked in the question?
We have to find the real roots of the polynomials given using Bairstow method.
Yeah. So we have to find the roots of a cubic polynomial using Bairstow method. So before going to actually finding the roots by Bairstow method, let us have a discussion first. So if you were given a simple uh, if you were given a simple cubic polynomial, then how would you go about finding the roots without knowing the Bairstow method? If like before you have been taught Bairstow method, you must be finding roots of at least some polynomials. So
Uh,
how would you go about it?
by judging the constant coefficient and the leading coefficient, dividing those two gives us the idea of what could the possible roots be.
Okay. So here you're saying that you will divide -4 and 1, and then what guess you make of roots? What can be the roots?
That the roots can be just integer factors of minus 4. That
Okay.
is 1 minus 1, 2 minus 2, 4 minus 4, and I'll guess on those numbers and check if those numbers are working. If one of them is the root, then great. If not, then we'll have. I mean, those are the only possible roots that we can get.
Okay.
By,
So
by the absolute root.
we determine by hit and trial one root. We determine one root by hit and trial, right? Isn't it? So one root uh, is determined by hit and trial, and we divide this whole by that by forming a polynomial of that root, isn't it? Hello.
Yes, yes, sir.
Yeah. So after that we divide and we find out a quadratic polynomial whose roots we can easily find out, right? So what is the method there we followed? That we take a cubic polynomial fx equals to ax cube plus bx square plus cx plus t, and we find out its roots by judging the value of d by a and factorizing it accordingly. So once we find one root, then we find out, we divide this by x minus, suppose this root is x1 or alpha, then we divide the whole polynomial by x minus alpha, and then we find out the corresponding quadratic polynomial which comes after it. Then after we get a quadratic polynomial or quadratic equation, so we can easily find out the roots of the quadratic polynomial by which method we find out.
Discriminant, like the formula for discriminant.
By the by that we find out, or discriminant uh, method, or discriminant method. So we have this way of finding the roots of a cubic polynomial. Now suppose the degree can be increased and the complexity of the problem can also be increased by, and we may not be able to judge all the possible roots by this method. Like a computer won't and can't do hit and trial. It does not, at least currently it can do in artificial intelligence world, but in the normal world it cannot do. By programming we cannot do a hit and trial cannot be done. Uh, so we have to find out a new method by which we can find out the roots of this cubic polynomial, right? So how we are going to go about it? So Bairstow is one of the iterative method. So as I have said before also that uh, we are not able to find the roots analytically, so we have to uh, find the roots numerically. So one of the famous method for finding out any thing numerically is iterative method. We do not have access to closed formula always, so we can always follow a particular algorithm, particular process iteratively to find out and go close to our answer, right? So here one such example is of a, is given of Bairstow method applied on cubic polynomial. So what uh, it says is, let me show you here only. Uh, so basically the given degree polynomial, like it is a 3-degree polynomial, so it is splitted in linear polynomial and a quadratic polynomial. And a reminder, this is nothing but just a remainder theorem, all of you are aware of this that, and you assume qx to be something like x square minus rx minus s, uh, and rest will be a 2-degree less polynomial. Like in the case of cubic, it will be a linear polynomial, and the remainder will be linear of 1 degree only, because it has to be of the degree less than that of divisor. Uh, so divisor here is this, so it has to be 1 degree less than this. So it is of degree 1 here. So uh, then we are just multiplying it and just finding, collecting the terms, collecting the coefficients of various terms like a constant term and a x term and a x square term and so on up till xn, and then we'll we can just find out this uh, x xi's and collect the coefficients. So after that, how we are going to get at the answer is uh, is that we choose a particular value of r and s by our wish. Initial guess, we can take whatever we want, and we have to iteratively go towards the actual RNS, because what we have taken initial guess may not be correct, so we have to go towards it. So what we can uh, measure is the change in R and the change in S. How much change in R will take place and how much change in S will take place. These two things we can determine this by this Berestorff method. So Berestorff method is nothing but basically we are uh, assuming a quadratic polynomial and finding out assuming initially this R and this is S, uh, and by that we find out what is the uh, what is the change in R and change in S, which will lead us to correct value of R and S. I hope all of you are getting it.
Sir,
Yeah.
for this method, is it kind of fixed that we have to assume the remainder like this format b0 plus b1 x minus r, or we can assume that like b1 x plus b0?
So you can assume anything, but accordingly the coefficients will vary. Like the formula which we'll be using will be direct here. If we go by this method now, so we get these coefficient directly by that. But if we do not assume and take it by our wish, then we have to change the altogether whole method. So here it is given that how can we find the C's, C coefficient C's, and the change in S and the change in R. How can we find? Now if we change it to B1x plus B0, then accordingly that will change. I hope you are getting it.
Oh, yes, sir, yes, sir.
So it is not recommended that you go by that method. However, if you want to practice it, you can definitely do it. It's certainly your wish. So there are basically uh, two things in this, that you have to find these coefficient b's, and the next coefficient what you have to find is c. Uh, so how you'll find the coefficient b's is by this. You already know an, and then you can predict what will be the value of an minus bn minus 1 and so on till b0. You have uh, you will have all the values of that, and similarly once you have all the b's you can find all the c's. This r and s are your guesses, present guesses. So by that you can find all the values of c0 to cn, whatever values you have to find, and then you can predict the change in s and the change in r based on the values of these b1 b0 c2 c3. So by this method you can find the change in s and the change in r, and the stopping condition, as I always say, that the stopping condition is of tolerance, how much uh, near we want our solution, like how much. So the relative tolerance is given by this, and here also you can use the similar logic, like squared error of the squared error, that the error this error square should be less than the tolerance uh, s- square, that you sum these, that EAR square plus epsilon AS square, you take its sum and do a under root and less than equals to tolerance. That is the stopping condition. I write it for you here. So epsilon A s square plus epsilon a r square to the under root less than tolerance. This is the stopping condition. Uh, and you are once you find the actual value of r and s, you can apply this formula to get the roots. Now, one question I have to ask you people, that why are we just using a quadratic polynomial? Why can't we use? Can we use linear one?
Sir, with quadratic, we can also get imaginary roots.
Yes, yes,
Yes.
exactly. So that's why we are taking x square minus rx minus s and not just x minus r or not just x minus s, because they won't be able to capture the imaginary roots, right? Because we will start our guess value with something real, and all of the coefficients that will calculate will also be real. So so the change what we will get will also be real. So once everything is real, so we cannot get something imaginary. So that's the flaw there. So we can only get uh, uh, real roots there, and here we can also get the imaginary roots. So very good. That was Ayush, right?
Yes, sir.
Yeah, so good, Ayush.
Hello,
So
sir.
yeah.
Sir, I have a doubt. If we have a cubic polynomial and we
Hmm.
write in that form, so we would write that in a means a linear into a quadratic.
Yeah,
This one. So we will find R and S
yeah.
after the stopping condition, and then we will find a quadratic, our
Right.
quotient. So for the linear wala part, we need to divide na whole cubic by that quadratic.
Uh, so you are continuously finding the coefficient b's, right? B you are continuously finding by this formula.
Yes.
So you already know the value of b. Of the at least of the last iteration, you would know where it ended. So you can take that also, and you'll already have the linear coefficients of the linear polynomial which you have to find. So you do not need to divide it. Am I clear?
Sir, I will get two roots. Like after getting R and S, I will have two roots.
Yeah,
So
but
how will I get the third root? Yes.
yeah, how we'll get the third root? So y- once you have R and S, you have this quadratic polynomial here, right? Right, and also simultaneously you are also finding out the values of b1, b2, b3, and so on up till bn. Aren't you finding out this?
Yes, 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 sir. Got it.
E- every iteration you are finding out this, so you can just put it there. That will do it. I hope I'm clear.
Yes, sir. Yes, sir. Yes, yes, sir. Got it. Thank you, sir.
So I'll give you guys 5 minutes. So think over it. How can we make a code, structured code? I have told bits and parts of it. So just try to structure it, and we'll discuss after 5 minutes how can we do it for our cubic case, and for in the sense any general. We can write general code also, like of 5 degree or 7 degree. We can write anything. So once we can do for cubic, we can write for anything. So just try and do it, and then we'll discuss. So Harshit, you are asking what should you take as an initial guess for RNS, right? So initial guess, we'll discuss it after 5 minutes when we'll be writing the code that what we should take as initial guesses for RNS. Right. So guys, have you all thought about it? So have you all thought about it? No. Would someone like to go ahead?
Hello, sir.
Would you like? Yeah. Okay, go ahead.
Yes,
Mm, Sir, like first we can take initial values of R and S.
Yes.
Then we can find all the B, like B0, B1, B2, B3, all of them. Uh, then we can find all the CIs, C0, C1 till Cn. So after that, we can use this matrix equation. This matrix C2, C3, C1, C2, and delta R delta S is equals to this vector minus B1 RS minus B0 RS. Then we can find the inverse of this C matrix and multiply it with the right hand side matrix minus b1 rs minus b0 rs. So after finding delta r delta s, we can find the updated value of r's, and we can do this thing until we converge. So when we converge, we have the final um, r and s. So like we will have two roots, and we also have all the b's. So then we can go for other roots.
Yeah. Okay, so this is perfect algorithm for a third degree polynomial, right? This is perfect. So once we decide, how we will decide the initial one, initial values of R and S. Stopping condition, I have already told what is stopping condition. So this is the stopping condition which you will have. So what modification should I make to make it for a general degree polynomial? This is perfect for third degree polynomial, cubic polynomial, perfect. No issues. How can we make it for a general polynomial? Someone have any thought?
Sir, first we can check the degree of the polynomial. Like when the person enters the a values, he will enter the degree also, right? So we can enter the a values. So if the degree is greater than 2, then we can use our algorithm, in which first we will update the bn minus 1 ourselves, and rest we can update by a loop. Same thing we will do for C and Cn minus 1, we will do it manually. Rest from n minus 2 to 1 C1, we can do it by the loop. Then we can use the formula for delta R delta S to get the values of these delta R delta S. Then we can find the updated values of R and S. Then we can check for the error. If the error is in the bound, then we can see that if that thing that comes under the root is positive or negative. If it is positive, then so we can directly use the formula because roots will be real. If it is negative, then we have to supply the iota from our side because the computer won't do it, I guess. And after that, we have to take the coefficients of b, I think, to get the next one, and then we can repeat.
Okay, so you just at the last you said the thing which I wanted. You have to repeat after getting the BIs. All the BIs you get, you put it under while one more while loop. You put it into that, and you just keep track of this number n minus 2 or something n, and you have to keep track of. Initial you will put n, then it will become after one loop it will become a polynomial of degree n minus 2. Then after that n minus 5 and n minus 4, sorry, uh, and so on up till what? Up till either it is a polynomial of degree 0, or it is a polynomial of degree 1, or it is a polynomial of degree. Can it be a polynomial of degree 2?
Sir,
Just
we
tell me.
can either stop on the degree 2 polynomial. We do not need a degree 0 polynomial because that would
Yeah.
not make any sense.
Yeah. So anyways you can do, you can, yeah, you can stop directly on degree to polynomial. So one and while the degree you can keep as Ayush said, you have to take it, the value of the degree initially from the user, or from the in the in the input variable you have to provide that. And while the degree is not equal to 1 or it is not equal to 2, you have to repeat the whole procedure on this polynomial. So I hope I'm clear there. Is it clear to all of you? Hello. So at the end of this loop, you have to uh, just assign the values of uh, this values of BIs to the new AIs. You have to update new AIs, and up and until the polynomial degree is not 1 or not 2, you have to run this upper loop, and inside this you have a polynomial of particular degree which you know. You have to reduce its degree by 2 and get a quadratic polynomial and find out the roots. So that's how you can find iteratively for all. Now I'm coming to initial values. So anybody have any guess what should we take as initial values? Hello.
Sir, like we can hit and trial sort of thing.
So what hit and trial we should take? So any number we can take, 1 4 or 0 1 1 or 0 0. What should we take? What do you think?
So we can take the coefficients of the means the coefficients which are in the equations,
Yes,
as
that,
Yeah.
as they are small as compared to the higher order terms, so we can take that.
yes, that is also a good suggestion. We can take the coefficient. So you can take anything. By the way, you can take anything 0 0 1 4 1 1 0 0, and as you said, coefficients and anything you can take. But my highest recommendation would be that you should take that what is R and S. Fundamentally, if you see a this is a quadratic
Sum and
equation. What
product. Sum and product.
this, yeah, this is sum and this is product. So what you should do is take initial value of R as the uh, a like the sum of all the of the original polynomial. Like we have, let me see what original polynomial did we had. What so this polynomial we had initially. Uh, so what is the sum of this? Sum of the roots of this? You're not audible. Whoever is trying to speak. So go ahead. What is the sum of the roots here?
So
Minus
minus of
an.
coefficient of
A n minus 1 upon a n.
Yeah. So this will be the sum, isn't it?
yes.
So so you can take it as R. You take it as R, and the product to be,
A naught
and the
by
uh,
a n.
product can yeah, a naught by a n minus 1 to the power n or n plus 1. I don't know that. So you can take it like that. N plus 1 will be good. Uh, so this will be the product and this will be the sum. So you can take the value of this to be this, like this. So is it fine now? Harshit, you had this doubt now? Hello, Harshit, is it clear now? And to everybody else, it is clear what you have to take initial guesses?
Yes, sir.
Yes.
Okay. Then, if anyone have any doubt, go ahead and ask it. Otherwise, the session is over. So we will wait 1 or 2 minutes more. If someone would have any doubt, he will go ahead. Otherwise, we'll end the session.
Sir, for term paper, we have to make team ourselves, or shall we be
Yeah,
assigned by someone?
you have to make it yourself, completely yourself. No issues.
Okay, and sir, can you give like some example that this is the journal and corresponding term paper would look like this or something kind of like that?
Uh, so we'll be uploading the samples of the term paper, uh, and you by that you will get the clear idea of what will be there in the term paper, how it look likes, and what is level 0, level 1, and level 2 term paper, and so on. So hope that is fine.
Okay, okay, sir.
Okay.
Sir, sir, in the tutorial, we have given a third degree polynomial. So, do we have to write our program for a third degree one? Like in this, we know now कि if we divide it by quadratic, we will get a linear. So, in the final step, we will just have to solve a linear. So, this much we know. So, we can optimize the program for a third degree only, right?
So that's your wish. Here we have kept it open ended. So whatever, if the we will not check it for higher degree polynomial. Just we want to make it clear. We will not check it for higher degree. So if you want to make it for third degree, it's your wish. And if you are want to extend it and try and hands on higher degree polynomial, that you have to find the roots of that higher degree polynomial by the square store method, then you can go ahead and do that. So it is completely open ended. Depends on you. Hope that is clear. Ayush?
Yes.
Yes, Tejas, go ahead.
Sir, actually, when it comes to the report thing, it creates a lot of confusion. Like in the assignment three, that do we have to always publish the error per iterations, or it's not compulsory? Because in reports, yeah, many times for each iteration we can give the graphs also, no? So it
So,
get
graph, either you give graph or you give the values. Uh, so how you'll make the graph? You'll make the graphs out of some values only, ना? You can ऐसा तो नहीं होगा कि डायरेक्टली C++ प्लस प्लस से ग्राफ बना रहे होंगे, मतलब ऐसा तो नहीं कर रहे होंगे ना, एक्सेल में ही कर रहे होंगे ना? Are you doing it by Excel or you are directly the graph?
Excel only.
Excel.
Sir, Excel.
So you can provide the Excel file to us. That would be fine. That would be great. And paste just the graph in the report. No issues. And
Sir,
provide
sir,
the
but
yeah.
sir, but like the previous one did not require graph, na? Because like, do we have to do that graph thing for every like that error graph we have to include in every assignment? Because it was not stated that you have to draw such things like that. I had included the stuff that was required corresponding to the question in my report file, but not the graph.
So uh, uh, till now it is fine that if it is stated till till now that you have to make it, then you had to do it, otherwise not. But now onwards, make it a point that you always have to draw the graph of error versus iterations. Otherwise you will never know that how the convergence is taking place. uh, like convergence will take place because the program has ended, but you should get a physical feel of it, that there is real convergence taking place and what is the phenomenon of convergence in every problem, so that it gets internalized in you. So it would be better if you always make your results uh, in the form of error versus iteration. So otherwise, results are not just how much you have produced. So results are how much you have done and how far you are from the actual one. So how far you are from actual one is shown by your error. So that would be a good practice if you always do this kind of error versus iteration and everything. Hope I'm clear for that.
Yes, sir. Yes, sir.
Sir, we have to provide one thing now, like we can share either Excel sheet or we can paste the graphs also in our report.
Yeah, you can paste the graphs in your report and provide us Excel file also. That would be fine.
So we have to do both, like we have to provide the Excel sheet and also we have to paste the graphs.
Yeah, do both. I'm saying
Okay.
that you cannot paste all the values in your report because that would make your report clumsy and all. So to make it short and sweet, you can always use the graphs.
Okay, sir.
So is it fine? Shall we call it a day?
Sir, like we will have two vivas, na. So like, uh, I mat- I didn't attend any of the viva because my name was not included in any of the list. So is it like there are some set of students who are left with like single viva after even after the minor?
Yes, yes. Till now for this, like 10 people from group 1 and 10 people from group 3, they've only, like, I've taken Viva for only 20 people till now. So, yes, I'll notify you a day before your Viva. Like, I'll post the list on the Teams.
Okay, ma'am.
Don't worry about it. So, don't worry about. Just be present when your slot comes. And if you're not available, like, uh, during that slot, or you're facing some health issues, like, please let me know, like, before the viva, so that I can schedule, like, I can give that slot to someone else. So that's it. Like, some people didn't know about the viva, that they have a slot on that day, and they were texting me after their slot, like after 6:30 or around 7. So I cannot, like, do anything afterwards. So just let me know before your viva slot. That's a request, and that's it.
Okay, guys, then we shall end the session. Thank you.
Thank you, sir.